Shalom. And just for the record, I'm living in Israel, so you can talk to me in Hebrew. I know how to speak Hebrew, on good. So today's talk is about serverless with server component. To be honest, I have zero idea why I chose the title, because it doesn't make any sense. It's serverless, server component, what the heck? It's everything about server here, right? What we're going to do in React. Well, to be honest, I want to change it to something called, let's drop React and change to Vue. That would be nice. No one laughed. Anyway, so just before our talk, as usual, let's talk about me. So I'm this angry rabbit. I'm Maya Shavin, and I'm from Microsoft. And I'm always angry like this, especially every time I have to do code review. Nah, just kidding, I'm not like that. I'm always smile like this. and in addition to that, I'm also co-maintainer of StorefrontUI, which is the e-commerce framework building on top of Vue. Yes. And I'm also an MBA of Cloudinary. I used to work for Cloudinary, and after I finished, I love it so much that I become an MBA for the company. I'm also a GDE, and I'm a Next ambassador. Next.js ambassador is about something like Next for server-side rendering, but in Vue, that's called Next. And I'm also a VueJS Israel organizer of founder community in Meetup. Yeah, you probably asked me, what the heck are you doing in React conference? The whole bio is all about Vue, right? Well, you know, it takes one person to take the first step to go into the React conference and tell how awesome Vue is. So that's me. Don't worry, not today. And in addition, yes, I'm also a book author. I just published a book, co-author, with several awesome people about how to develop projects on front end with Vue.js. And I like to draw something like a rabbit, like angry rabbit like that. And yes, so if you ever want to switch from React to Vue, feel free to buy it. Or you can always ask me, I give you a free copy. Anyway, that's enough with the blah, blah, blah. Let's talk about our talk today, is rendering. So, one question before we continue. How many ways of rendering do we have for an applications? Guys, raise your hand, say something. Okay, you say. Sorry, cannot hear? Server-side and client-side. Well, technically, you are right. We have server-side and we have client-side rendering. What's the difference? The difference in how the browser handling the resources and how the browser rendering the application on the client side. Which for client-side rendering, CSR, everything have to wait until all the resources is loaded and the browser execute React, because we are using React, we're using Virtual DOM, so we need to execute React on the browser in order for our app to run. And then only then the user will be able to interact with our application and will be able to view something. In the other hand, with server-side rendering, like you probably already know, the difference is that now on the UI, on the HTML will be pre-rendered before it's served to the client side, and the browser only needs to download the JavaScript, additional JavaScript bundle, and then execute the React, which means while user waiting for React to execute and initialize the application, he already can see a little bit what the UI on the client side. The downside of it, there's a lot of downside, and that's the battle that we've been trying to fight over years between how to make server-side rendering as the same like client-side rendering and so on. So we kind of come up with 5 different ways of rendering in addition from this. So from two fully client-side, and it's fully server-side. We got to static side, server-side rendering, which is everything will build as HTML. It's static side. It's like Jamstack, if you know what is Jamstack. No CS, no JavaScript, nothing, only HTML. Or SSR with rehydrations. This is a very common approach nowadays with Next and any server-side framework. Or CSR for pre-rendering, which is Gatsby. So if anyone here using Gatsby? Cool. I haven't used it, so I heard a good thing about it. So yeah, I'm just blah, 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 so don't mind me. Anyway, so this is the file. Then each of them have different trade-offs, and each of them trying to show something. In general, server-side rendering always slower than client-side in terms of time to first byte, because it has to load the HTML, and HTML is very heavy. So what about, now next questions, what about serverless? Because after all, the talk is about serverless applications. And what is serverless SSR? To be honest, serverless is not about rendering. It's not also about not server, yes, server. It's actually about the new type of cloud computing where instead of building a one big, chunk, huge, monolith applications server, like web server, now we split it into even smaller than microservices called functions. And everything will be served through APIs and through API gateway, which means from client side, when user want to query a specific interaction, specific actions like query for products, it will, the server will know the API gateway like AWS, like Google Cloud Platform, and of course Azure. Since I'm working for Microsoft, I need to mention that. If not, they will not happy with that. Anyway, so API gateway would know exactly what functions to map to the specific API. And this means when user query for products, it will only map it to the products function, totally isolated from the rest of the server or of the other APIs, and the product function only knows to interact with products database. Similar to others, and similar when user actually make a purchase by actions, and the buy action will be triggered, and then the buy actually only talk to the product database to interact, and maybe talk to the user database, who knows. But that's a different story, so the whole structure becomes super simple and super minor and easier to maintain. But again, what exactly is serverless? And we'll say, in this talk, we're talking about serverless server-side rendering, serverless SSR. Serverless can be also serverless client-side rendering because actually serverless is all about the server, nothing about the UI or the front end. So by the term serverless, it's actually a very bad name, you know, because it doesn't say anything about the real meaning of serverless. It's not that you don't have a server. It actually, you still need a server, but you don't need that monolith server. Which means, hey, bye-bye, I don't need that huge thing that who knows how to maintain it. I can actually destructure that big monolith server and make it to small things, little things, and use it from there. And yeah, and if you do serverless SSR, you still need to do server-side rendering, which means your UI still need to render on the server. The same thing, serve, and you can choose to render in the 5 different ways that we talk about. So that is serverless. So I hope it's clear now. And if it's not, I don't know. Anyway, so next, we're talking about fetching. How many ways are there in React application or just any front-end applications to fetch data? Fetch and render data. Anyone knows? Sorry? A lot. A lot is a lot, you know. Give me a number. Okay, that's a lot. To be honest, you only have 3. Like 3 main things. First, RAF, okay, I make up that word, so never mind. Render as you fetch. Fetch first, render later, and fetch as you render. Sounds good so far? So, render as you fetch, meaning you fetch the data in parallel of rendering kind of all the resource that you need in order for render the component on the client side. It will be fetched, and when the component is rendering, and actually the component don't stop render to wait for the fetch data to complete. In the other hand, it actually render whatever don't need to rely on the data, like a header, footer, or an icon, or a button, and while waiting for the fetch data to complete and continue with it. This approach is very trendy right now with suspend and concurrent mode in React. And React 18 come up with a new way of suspend, which I heard is very good. So later today, I think there will talk about suspend, if not wrong. So yeah, you should check it out. But one thing about this approach that even if you say render as you fetch, it still would not be able to do it without the ability to fetch first, render later. Because anyway, you need to know what to fetch in order to render whatever doesn't need to rely on that. So let's come to the second approach, fetch first, render later. So what is fetch first, render later? It's the same like we said. First, in initial load, you fetch everything on the data, on the result, you stop the render. You wait until the fetch complete, and then you render the whole page at once. This is the way the website works long time ago until today, before we have React. And still, until now, we have something called prefetch mechanism. It's actually go according to this strategy, which means when the application detects the user are likely to go to a next page, it will try to refetch on the data of the next page before the user actually go there. So once the user click on that link, it will already finish loading on the data needed, and it only needs to render on the page, and the user experience will be much better. But the downside is that if user do a refresh on the same page, you still do the whole thing again. Fetch data, wait for data to complete, and then rendering. So which means user will probably see the blank page until something displayed there, or a spinner. Okay, the last one. This is the interesting one. And actually, this is the main one of our talk also. Fetch as you render. And why they have a waterfall here, there's a reason, because it's in the other way, in the community, we call it React render waterfall. Basically, what it means is that data is fetched inside the component while rendering, or in the other hand, that you render the component, you fetch the data, and then you continue render the component, and the whole process continue with your child. How does it go? Okay, how does it go? In the component, you load on the bundle that needed to build the component. You render the component. While render, fetch the data using React hooks like using fetch or component will mount or update mount or component will update whatsoever. And then once it's finished, you update the component, you continue render and the child. You reach to now you render the child component. And in the child component, if the child component relied on some data from external data, you continue the whole thing, load the bundle, load the code, render the component, fetch the data, update it, continue on the way to on the child's, on the low down. And that's why it looks like a waterfall. The downside of this approach is that it has no outside control over the data. Only when you reach to the component, you know that you're going to get data. The component knows what he wants to get, not you, from outside. And you cannot fetch until the component is rendered. And that's why you have the whole waterfall, because children component have to wait for the parents to finish render before it finish fetching data before it can render. The bundle size, well, that's always been the problem in almost all the approaches. And like I said, children can render until parents' data fetch it. Unfortunately, this approach is very common in React. Almost all React applications have been implemented with this approach. And that's why the React team, in order to try to improve the Waterfall, the React Waterfall, they came up with something, sorry. I actually forgot. This is another problem because the children have to wait until the parents' data finish to render. So sometimes you get into this situation when the user actually sees something, but it haven't finished rendering. And then suddenly he saw something appear on top and push everything down, and he accidentally make an order of 56 items instead of canceling it. And this is why it's kind of bad user experience. And the terminology for that is cumulate layout shift. You can read about it on Google. I don't have enough time to explain about it, but yeah, you have got the idea. So to solve these waterfall problems, the React team come up with server component. So what is the server component? Server component, first of all, it's component on the server, right? No, it's not. You still write the component, but the component is rendered on the server, but it's not server-side rendering because it doesn't render into HTML. It renders into a different format. And the idea is that it's supposed to have zero impact on the bundle size. What does that mean? That means that whatever code that you write to build this component will not be shipped together with the bundle code to the client side, because it's not supposed to be there. And it's stateless, so that's why it doesn't affect any state of the applications at all. And the component, because it's rendered on the server side, it has direct access to all the backend functionality like query, GraphQL query, like query for data, API query without sending requests through the on the browser. So now suddenly your application will be something like this, which means you can have half of the, it's very hard to say, not to say hesi and say half. Anyway, so the application now can be the combination between half of the client component and half of server component. Or even have shared component, which is the shared component is the combined between server component and client component. It can be server, it also can be client. Yep, I know, that's a lot of things to take, thinking about refactoring your code. So now the naming conventions, very simple, just before you have component A, B, one component is server, one component client, one is shared component. Now you'll be component A.server, which indicate to the compiler this component is for the server. Component B.client.js, client.js, tell the compiler that this is only for the client, and we only bundle it for client. And the shared component is the combination of both. Well, the shared component is like the normal React component where you can put component A and component B together inside it. How it works? Like I said before, 100% static. Absolutely no user effect, no use effect, use state, anything that can create a local state, update state of the application. It's completely isolated from the application state. No interactive event listener, which means don't even try to render input, because input will not, you cannot attach any on, click on, change on anything on that component, unlike server-side rendering. And it's only render when it needs. If it's not needed, the template itself will only have a markup code template inside the HTML. When it's needed, it will send a request to the server to get the component. And, well, yeah, I know. I know, it's hard to explain to you guys without showing some code. So let's show some code, how I'm doing them. I have 6 minutes, so I hope I can show you all the code. Can anyone see it? Good? Sure? Okay. So this is the demo I took from Next.js. It's built on top of Next.js. It's a server-side rendering framework, and it's backed up by Vercel, which is a hosting platform for serverless function and so on. So it's super cool. I just kind of delete all the component there and add my Pokemon inside. So now I have a Pokemon file component which will just render the detail of the Pokemon. And I have get Pokemons here, which is the GraphQL query to query the information about the Pokemon and display. And here I have a server-side render, which will just fetch the data and render the component inside. And I have a CSR, which is client-side, the classic client-side, which will also use suspend to implement the fetch. I think it's render while you fetch, something like that. And let's see how it looks first. So in the server-side rendering, you can see if you go into refresh, it looks cute though. Come on. Oh no, I'm not in the correct, so let's see. Okay, let's try. I hope my internet is good. But anyway, while waiting, so if you look at the SSR, there's only one that returned probably also the image here. But anyway, so it's supposed to, you will not see the data, like the JSON object on the data. Here, you only see the HTML return. And it's waiting for localhost. Damn it. Oops. And anyway, so, and client side, no, client side. If you go to the network of client side, you will see on everything. Like if you query for each of the Pokemon, you will see each of the requests here. Each request will again go back with all the data here. Right, all good. Okay, now I want to change the Pokemon to be a server-side server component. So I would just have a Pokemon.server. And notice here that because I'm using Cloudinary, and before in the other one, which is Pokemon, I don't use it because the use Cloudinary, which was triggered on the client side. In the server component, it doesn't know that, so you need to kind of put it back to it again. And the code is the same, nothing changed. You just need to rename from Pokemon to Pokemon.server. And now I'm going to RSCS, which is React Server Component. And I'm just import this. And now I'm just remove and have the Pokemon with the data. And I'm only display 30 Pokemon just for the sake of it. And I'm also implement suspend here. And once in suspend, it will render skeleton instead. And I'm safe. And let's see, how is the component? Okay. SSR, no. Ah, it should work. Yes, it works, okay. Anyway, you will never know what happened in live coding. Okay? So if we look at the network here, when you go to the HTML page render here, it actually, no, not here. I will go inside here, and then if you go to template, you will see in the page, in the place of on the Pokemon, you will have on the template instead of the div, and with an ID. This is how React will know how to map the React component fetch from the server to the correct place. And if you look at the flight, which is this is the response from the this is the React component, the server component. the response like this. It's not JSON. It's some kind of weird format. That's new kind. Probably they will call it meta JSON or something. Well, you know, like metaverse. And so it contains all the information about this. Also here, if you look at it, we have these things that interactive, but I cannot do the same thing because this is local state. This is you change the state of this component, but I cannot do the same thing in here because it wouldn't work, because use state don't work. So if you want to do that, you need to actually change, oh, sorry, just 1 second. If you look at the Webpack here, in the component, you wouldn't see Pokemon at all. Pokemon client, because it's not there. It's not included in the bundle. And that's one thing. And if you want to actually have it interactive, you need to change the server to Pokemon and rename. And then you need to change the Pokemon to client. And now it works. And, your fit. Should work. It still works, but now the entire component is in the client side. And if you go to, what happened to my, the right one? How come it doesn't have anything here? Okay. Anyway, I'm pretty late for my talk. So it's supposed to show you also the Pokemon.client.js inside the Webpack. So you got what I mean. I'm sure it will be there, just the internet doesn't work for me, and I'm pretty late, so let's continue with our talk then. Okay, cool. Okay, so the pros here. Well, the good things about React server component is that it's make this bundle smaller, which means now you can load the bundle size faster, which means the user can see the page faster and can interact with the page much faster than server-side rendering. And it's because you can use the same code for client and server-side, like you say. I don't need to do a lot of work. I just need to change the name convention to .client and .server, and it just works out the box. So now it's much easier to maintain, and also it's much easier to indicate to the next developer which one is server-side. It makes the backend simplify because the backend code, this backend now can talk directly to the server component regarding any data that they don't want to expose to the user side. And there's no impact again. And there's one more thing, is live streaming component, live updates, which means whatever you change on the server will be reflected on the client side instantly, without you need to do any sockets, any listener. But we don't have time for it, so I didn't do it in the demo. But here come the problems. Why server component would not be that great idea? Well, first of all, the response size. You know that in the normal client-side rendering, the response is JSON, and JSON is pretty small, which is very small for, this is for 100 Pokemon's query, only 4 kilobytes. But with server component, it's jump up to 30.6, almost 31 kilobytes for one request, just for render the list of Pokemons. And this, you cannot really use JSON to interpret. You need to use a compiler to actually know how to interpret this format. So I'm not sure this is a good trade-off for that, because it means that you increase the response will be much heavier. Okay, the next thing is frequency. In the SSR, normal SSR, everything will be rendered at once at initial load on the HTML, and there's no need for anything in addition. Normal cache is good, but for server-side component, server component, on the server component will be refreshed multiple times equally to multiple requests on the network tab. And you cannot do it by yourself. You need to implement your own caching in order to limit down the number of times for fetching rendering, re-rendering the server component for each user interaction. For example, click on create record, click on submit, do highlight something. Every small interaction can cause it to fetch the component again and render again. And that means we have a huge trade-off here. You technically trade off the bundle size with zero impact with a lot of network requests. Do you want to do that? If the network request is very big, are we ready for something like that? Well, let's Holmes decide for us. Holmes? And I let you decide for that. And to wrap it up, serverless is definitely a future for our applications, but not yet for server component. I play with it. I like the idea, but it's not there yet. It's only good for good and simple, non-interactive component like header, footer, some information, some text, but definitely not for list rendering. Think about 100, yes, I know, 100 Pokemons. You have to have 100 server component in that single response, which is like 9 times different. And wait and see. And some resource for it, and that's it. Thank you. I hope you enjoy.